It took me a really long time before I even realised what circuit networks were for. Then once I had understood, so that's what you do, it took me another really long time before it felt like I knew how to use them and get them to do what I wanted them to do. And now that I have this basic understanding, and it is a basic understanding, when taken to their limits, these circuit networks are capable of some pretty incredible stuff. But now that I have it, I like to use the circuit networks as much as possible. They are a really fun addition to the Factorio toolbox. Hello, I'm Bigfoot, and today I'm going to try and show how circuit networks work, how to use them and get the best of them, and then I'm going to take you through a few of my favourite examples. As always, the basics first. There are two different colour circuit networks, a green one and a red one, and that concludes the differences between the two. They are different colours and that is it. They function the same and they cost the same and they do the exact same thing. All it means by having two colours is that we can have two circuit networks running along the same routes whilst keeping their values separate. What if I want more colours, I hear you cry? Well, tough diddums, two is all you get. Jokes aside, if you need more colours, there is almost certainly a mod out there. I haven't looked because I haven't ever found the need for more than the green and red wires. Most of the time you will only need a single colour. The way these wires work is that we select it from the inventory and then click on a thing, and then we click on a power pole, and then we click on another thing that we want the first thing to connect with. More on the things in a moment. We essentially connect two things together through the electric pole and over the power network. If we need to connect these two things over large distances, then we can use power poles to string the circuit network over. If we are constructing a really big network, then obviously we want to use the large poles. In the example we have on the screen, we have two chests and a single electrical pole. I'm going to select the red colour wire from the inventory and then click on the first chest, then on the electrical pole, and then on the second chest. I have now connected these three elements to the red circuit network. I'm going to put 10 barrels in the first chest and then another 10 barrels in the second chest. By hovering our mouse over the electrical pole, we can see the values that the circuit network is communicating, and what we see is 20 barrels with a red coloured background. So because the item in the chests are the same item, and because they are connected with the same colour wire, the circuit network adds the totals together, and that is the value that is communicated to the network. If we take the same example, but connect each chest to the electrical pole with a different colour wire, then the values that are communicated are 10 barrels through the red network and 10 barrels through the green network. This is how the two different colour wires work. If you need to transfer the same variable over the same network, then you will need a different colour wire for each. If the variables are different, i.e. you want barrels in one chest and say green chips in another, then you can use the same colour wire because the network won't add the two values together. This is essentially why a single colour wire will mostly get the job done. Now to the things, and the best way to think of them is in the following categories. Number 1, detection. We need to detect a value. This is the first step in the chain. Number 2, operation or calculation. We need to take that original value and either perform an operation on it, so less than or greater than, etc., or use it as a variable as part of a calculation. Number 3, action, which is almost the final step in the chain. We then need to use a thing to perform an operation that is dependent on either the original value or the operated or calculated value. Number 4, miscellaneous. There are some miscellaneous objects that are useful, and we will come to these later, but these are the three main categories to concentrate on. Now this might all seem complicated, and it probably isn't helped by the specific language I'm using. I am a technical person at heart, what can I say? But it is relatively simple when it is put into action. There are some processes in Factorio that we don't want to occur all the time. We only want them to happen when specific conditions are true or false. The way we trigger those actions to take place or not take place is by linking a thing which detects a critical value with another thing which will act on that critical value, and thus we can start and stop the processes in the factory automatically without any intervention. I will get into specific examples later, but this is the core concept of circuit networks. Okay, so what things? Number 1, detection. There are a couple of different objects that can detect a value, but I find the most common to be the storage chests. If we link a storage chest to a circuit network, then whatever is put in that storage chest will be communicated to the network as a value to be acted on. Storage tanks work in the exact same way for liquids. Conveyor belts can also act as detection. If we untick the Enable Disable box and tick the Read Belt Contents box, then we can link a conveyor belt to a circuit network and it will detect how many things are on that particular bit of belt and send it to the network. Pulse only records when the item enters the belt. I think you use this if you are trying to count the total number of things passing through the belts. I don't know, I've never found a use for this tick box. And hold it if you want the belt to continuously send the contents of the belt to the network. The capacity of a belt is 7.5 things, and it can sometimes be useful to connect 4 or 5 consecutive pieces of conveyor belt to the network and take an average. A single belt on its own will give hugely variable results. Several belts connected together will produce a much more even, reliable set of actionable values. In the exact same way, inserters can act as detection, sending whatever they are holding or have picked up, but I haven't ever found a use for this. The same pulse and hold options are available, and they do the same things as for the conveyor belts. That is probably it for detection, factory speaking. There are a couple more detection objects that work specifically on train networks, but I am no expert in that field, having never really tried it. For the time being, I'm going to concentrate on factory specific networks, and if this whets your appetite, then maybe go and have a play with the train networks on your own and see what you can come up with. So number 2, operations or calculations. In the vanilla game, there are only 2 objects that can perform an operation or calculation on a value, and they are the combinators. If we want to do a calculation on a value, then we use the arithmetic combinator, and if we want to perform a logical operation on a value, then we use the decider combinator. Each one can only perform a single operation, so if you have a complicated algorithm, then you will need a combinator for every step in the process. This is something that is more difficult to explain without examples, so I will go through in a bit more detail at the end. They are probably a bit more on the slightly advanced side of things. If you are only just getting started with circuit networks, then there are much easier things to do that are incredibly useful before you get to these slightly more obscure bits of kit. There are also mods out there that can do things on values that I can't even comprehend. Programming stuff, out of my league stuff. It is out there if you want it, but I'm not touching it. Number 3, action. By far the most common thing I use to action a value on a circuit network is an inserter. And yes, I know I mentioned them in detection. Inserters can behave as a detection thing and also an action thing. The way we do this is by selecting the Enable Disable tick box and setting the value in the box below, which dictates when we want the inserter to switch on. I don't really use them much as detection, but I use them hundreds of times for action in every factory I make. They can act on a value in ways that are just so damn useful. Conveyor belts can also act as an action thing, so it can switch on and off depending on what you set in the box below, just like with the inserters. Useful? Yes, undoubtedly. Do I use it very often? No. Do I have any reasons why I don't use it very often? No. Lights are also really fun and a useful thing to have on a circuit network. We can set them to come on and off at various values and use colours if we want something to stand out. If you have a process that you need to constantly check up on, then set up some lights to indicate the thing you are checking and bingo, you can now see the status of your factory at a moment's glance. Examples are coming soon, I promise. And number 4, miscellaneous. In this category, I'm going to put the switch and the constant combinator, which are basically the same thing, except a switch will set a single value and can be operated from the game screen by clicking and turning the switch on or off, and a constant combinator can set multiple values but can only be operated by entering its menu and turning it on. They just provide constant values to the network to run in the background whenever they are switched on or off by you. But again, their use is pretty niche and is best illustrated with examples. So that is the basic list of things that can be used on the circuit network. It isn't a complete list. I haven't included the power switch, for example, for the simple reason that I haven't ever found a use for it. This list of things is the list of things I have at the very least found a tenuous use for at some point or other, and there are just some things I don't know how to use. Okay, so for the examples. Example number 1 is probably the most simple but common way that I use circuit networks. Let's say you want some walls. You set up a chest next to the conveyor belt with the walls on it and you add an inserter. That inserter will fill up the chest with walls. You take the walls and you go use the walls, but you don't use all of the walls. When you come back to the chest to put the walls back in it, the inserter has filled it up again, so there isn't any space for the stuff you want to put back in. Problem. So let's connect the inserter to the chest with one of the circuit wires. The chest will detect how many walls have been placed in it, and the inserter will act on that value. A steel chest will hold 4,800 walls. If we set the inserter to only pick up from the conveyor belt when the amount in the chest is less than, say, 2,400, half the total capacity, then there will always be at least 2,400 wall for you to use and 2,400 space for any walls you don't use and want to put back in. If we change the steel chest for a logistic storage chest and select walls as the stored item, then the same thing will happen for the robot network. If they need walls, they can pick them up, and if some walls need to be put back into the system, then there is always some space available. I probably have about 100 of these set up around each and every factory I make for all the different factory ingredients I need to use. But it goes a bit further than that. When I build the factory, I do it with yellow conveyor belts, and at some point a lot of these will need to be upgraded to red or blue ones. This chest setup is a dead end. The robot network will put the belts back in the box, but they will stay there. Also, for this upgrade process we are talking thousands of belts, potentially dozens of boxes worth, just sitting around stuck. So for particular items, I like to construct little collections of storage boxes that also feed back into the rest of the factory. Any belts that are put into these boxes will eventually get used or upgraded, and they don't end up sitting around doing nothing. It doesn't stop there either. Yellow conveyor belts are cheap and really easy to construct. As long as you have enough iron, you will have enough yellow conveyor belts. But ammunition, particularly red ammunition, is expensive and slow. With the same setup I just went through, I have always found the storage boxes empty of ammunition because the factory processes were struggling to just fill the conveyor belts that led to the turrets. So now I hook up the outgoing inserter as well as the incoming one to the storage chest via the circuit network, so that there is always a minimum amount of ammo in the storage chest for me to use if I need it. If we say set a limit of 1,000 red ammunition on the incoming inserter, then the incoming inserter will always be on if there is less than 1,000 in the box. If we then set a limit of greater than, say, 800 on the outgoing inserter, then it will only take out of the box when its contents are greater than 800. So if we need red ammunition, there will always be at least 800 for us to use. Any ammunition over 800 will be fed to the conveyor belts along the perimeter wall, and the boxes themselves will only ever fill up to a maximum of 1,000 before the incoming inserter will stop. If we need to put red ammunition back in the boxes, which happens a lot for me when I'm moving my perimeter walls to increase the factory size, there will always be space available. I think that just about covers it for example 1. Example number 2, lights. Now lights might not seem all that fundamental to your factory. They aren't going to action anything, they don't do anything directly for your factory. But as I stated earlier, there are some processes that require occasional attention from our Factorio dude, and it can be useful to set up lights so we can see at a glance the status of any particular part of the factory process that we are concerned about. In my vanilla factories, I generally have a big store of coal because I want to have security of supply of coal for my steam furnaces so that I know I will always have power. Over time, any coal mines that are feeding this big store will deplete and the amount of coal in the system will slowly reduce. But from the outside, it isn't immediately obvious, and I've been caught short on more than one occasion, having to scramble around for new sources of coal at very short notice. So what I do now is connect all of the chests to a single network to get a total amount of coal stored. I then calculate the total capacity of all the storage chests added together so that I can work out the amount of stored coal as a proportion of the total. And then depending on that proportion, I set a series of lights to come on to show me how much coal is in the system. In the example on the screen, which is my racetrack base, you can see this kind of setup. So if we take a blueprint of the entire screen, we can see that there are 480 storage chests and 32 steel chests. For some reason, I haven't upgraded some of these, that's my bad. 512 total number of chests times 2,400 coal per chest gives us 1.229 million. That is the total capacity of the system. And I have 19 rows of lights here in this big array, so each row of lights needs to come on at increasing values of 1.229 million divided by 19, which is 64,673, to give the effect I'm looking for. If I click through each light, you can see the critical value slowly increasing. I also have this little screen here which displays the output of the total number of coal stored. This is a useful little mod, this one. For the colours, we can go a couple of ways. We can set all of the lights to be the same colour by simply connecting a constant combinator to the circuit network and tell it to output the colour we want to use. All of the lights will be the same colour. We can also use two colours pretty easily by replacing that combinator with two of its decider brothers and setting each one to be less than a value, or the other one which would be a greater than a particular value, that same value, and then the colour we want it to be for those particular values. These systems are really simple and straightforward, and as such I'm hoping that a verbal description will suffice, with on-screen prompts of course, because I don't really have many examples. I tend towards the more difficult examples. Back to the racetrack base, and for this I use the next up in complexity. For this setup I have a single constant combinator connected to the same network as the rows of lights I want to be the same colour, using the opposite colour wire that I use for the rest of the system. The lights only have a use colour option, so if you have multiple colours connected to the same light, it will pick a colour based on its own internal programming. If we want to pick the colour in the way shown on the screen with different colours for different rows, then we need to separate the colours from the rest of the network so we can dictate which colours are used for those different rows. So every light is connected to every chest with the red colour wire, and all of the lights that we want to be a specific colour are connected together with the green wire to a single constant combinator that has the colour selected that we want to use for those rows. The values that those lights turn on at is set by the proportion of the total and use capacities as stated before. That hasn't changed. The next most complicated method is as seen here in my 2000 SPM version 2 base. Here the colours of the whole array change depending on the capacity being utilised, not just the individual rows. This is a bit more tricky to set up and requires the use of some of the exotic combinators. Essentially what we want to do is create a range where certain colours are switched on between that range and then communicated to the lights via the network. The bottom and top values in the range are always easy. If value is less than or more than the critical value, then output the colour. We can set that in just a single combinator. For any values in between, we need to set two values, one for the upper limit and one for the lower limit. For each of these we are going to output one of these letters in this menu, say A, a value of 1. So if the critical value is greater than the first value in the range, then the first combinator will output A equals 1. And if it is less than the second value, it will also output A equals 1. And added together it will become A equals 2. A will only ever equal 2 when the critical value is between these two values in the range. And so in another combinator we set if A equals 2, then output colour for that range of colours. We need to set up this little collection of combinators for each of the colours that we want to use and then connect all of that to the lights. It is a complicated setup, definitely, and it only achieves the same basic function as all the other methods via a convoluted method which is much more work. But if you're into circuit networks and you're into Factorio, isn't that the whole point of the game? Now it may seem like I've gone into a lot of detail about these lights, when really they don't have a whole lot of direct use in the game. And you would be right. I am hoping that by going through these examples, you gain a basic understanding of what is possible using these circuit networks, and so can find uses for them beyond the scope of this tutorial. I can't imagine every factory situation where they might be useful. You will undoubtedly be doing something different to what I do, and as such you might have different problems than me. But hopefully by going through these simple examples with lights, setting ranges, understanding how the colours work, the kind of inputs required in the combinators, you will understand how to use the same principles for different purposes and come up with different examples. Okay, so on to number 3. There was a period of time between getting cheesed off with continually getting hit by my own trains and discovering the jetpack mod, where I decided to build paths around my factories with specific gated junctions where they cross paths with train tracks. I wanted to construct a series of gates which opened and closed when a train was approaching, and thus physically prevent myself from being hit by the things. Man, sometimes I swear those trains are hunting me down, plotting and waiting for the most opportune moment to strike. Anyway, these junctions have evolved a bit, and now what I have is a series of gates and lights that open, close, or change colours depending on the train situation. It goes like this. Connect the incoming train signals of the junction to a network, and connect that to the lights you want to change colour and the gates you want to open and close. Go into both of the incoming train signals and change the middle colour to red. I like to keep things simple, 2 colours is enough for me. If the colour is amber, I want to protect my little dude and assume it is as bad as the red signal. Set all of the lights to turn on when L equals 0, i.e. we want them on all the time, and set them to use colours. they will now indicate the same colour that the train signals are outputting. With the gates we want open when the train is approaching, we want to set it to open when red signal is greater than 0, i.e. any red signal from the train line, and these gates will immediately open. With the gates we want closed when a train is approaching, we want them open when red signals are 0. I always set another gate 5 tiles back, which will open and close whenever it feels like it, i.e. not connected to the same network, and that is where I place these train signals. There is a slight time delay between the red signal being registered on the network and the gate fully opening, and I tend to find 5 tiles to be enough space for that to happen by the time the train has arrived at the junction. And hey presto, suicide by train mostly successfully prevented. Just as a side note, the gate also happens to be a thing, which can be a detection thing and an action thing. In this example, it is an action thing, being dictated by the train signals, but we can also set it to detect, and it will send a signal whenever it is open, effectively acting as a proximity sensor for our little dude. You can essentially use the gate to insert our dude's position into the circuit network. Do I know how to use this to make an awesome thing? Nope. And if you are using gates on a circuit network, be aware that we can only connect them at a junction with a wall, so we can't control it if it is out in the middle of nowhere. And if you are connecting multiple gates in close proximity, be careful to keep the connections at the corners separate. It is very easy for 2 gates to be connected to the same piece of wall with different required input values, and this obviously won't work. You might need to rearrange your gates with gaps to get it to work the way you want. By this point, I'm hoping that you understand the basic principles of what I'm trying to explain. How things connect together, how to manipulate values to get the network to action that in the particular ways we desire, and in particular how this can be useful to us, but maybe not necessarily the factory. From here we are going to dive into slightly more advanced topics, which I have found to be incredibly useful for the functionality of my factories. So example number 4, uranium and the Cover-X process. The goal of the Cover-X process, in my opinion, is to maintain the correct proportion of U-238 and U-235 in the system for nuclear fuel. I want 19 times more U-235 than U-238 because that is the proportion required. The problem is that we start with a much lower value, and we need Cover-X to not only increase that proportion, but also switch off at the right moment so we don't end up with a situation where everything is U-235. And the right moment for it to switch off is when the amount of U-235 is 19 times less than the U-238 in the system. That is the trigger. So we need 2 separate and different groups of storage chests for each of these elements so we can store this stuff, compare their values over the circuit network, and switch off Cover-X at the right moment. For U-238, we just want a lot of boxes all linked together. For this we only need mass storage. Any processes that use this as an ingredient or give it off as a byproduct do so very slowly, so throughput isn't critical. Number of boxes is. Feeding in and out to all the relevant bits of the factory. For U-235, we will eventually be feeding Cover-X with an incredible amount of material. It is a hungry beast, and the beast takes its time with its meal. Progress is slow, so the faster and more efficient you can make the process, the better. In my latest setup, I only have 8 storage chests here, but you can see that I pay a lot of attention to maintaining an even flow to all of the chests, to try and keep the contents of the boxes even. For U-235, we only need a handful of chests, but they need to be placed in such a way that they are as evenly loaded and unloaded as possible. It is incredibly easy for all of the U-235 to end up in just one box that is only loading half a conveyor belt, and then you have lost 50% of your efficiency. We then need some kind of switch that stops the flow of the U-235 to Cover-X and moves it over to nuclear fuel production. I tend to use inserters out of the U-235 block I have already created. I have 2 output belts from the block for this purpose, but it's probably just as easily achieved with a couple of conveyor belts that switch on or off. Once we have our storage systems for each of the elements set up, we link all of it together on the same circuit network. In an arithmetic combinator, we want to divide the number of U-238 in the system by the number of U-235 and set the output to be a value. I tend to choose Z. So if Z is greater than 19, we want the Cover-X process to run, and if Z is less than 19, we want the process to stop and for nuclear fuel to be created. We also need one more thing. During the early stages, you won't have any U-235 in the system, so in the calculation we will be dividing U-238 by 0. Factorio doesn't like this. So in addition to all of this, we need a constant combinator set with a value of U-235 equals 1, and now the result of the calculation will always be a rational, actionable value. Example number 5, oil. This tutorial is probably starting to drag on a bit, so I'll keep things brief from here on. Oil is a tricky thing to set up correctly with the right proportion of machines and refineries. But once you have built it, it is important that the system maintains some kind of balance so that all the processes can take place without a tank or pipe filling and blocking up everything. If you are interested in finding out how to use the circuit network to regulate your oil process, I would highly recommend checking out my oil and SPM tutorial. It goes through the whole process in detail, showing how to calculate the outputs and get the various parts to run and shut down when they need to. You might not find the whole video interesting, you might want to skip the calculation part, that's fair enough, but there is a bit at the end on how to set up the circuit networks that you might find useful. Okay, plug over. And finally, example number 6. A few have commented about the rocket procedure I build in my factories, where the surrounding lights illuminate in sequence as the build of the rocket progresses. In order to achieve this, you will need to download a mod, the inventory sensor, and this thing can detect various values from things not covered in vanilla, one of which, when placed next to a rocket silo, is the rocket progress. Then, much as the same with the lights from earlier, it is just a case of setting up all the right values in the lights and value ranges in the combinators for the colours. This combinator has a lot of potential. I don't think I've really grazed the surface with what it is capable of doing. The number of practical uses is probably many. Okay, so I think that is everything I have to give on circuit networks, and it is probably the most comprehensive tutorial I'll ever make. But the reason is simple. The number of different ways these circuit networks can be arranged is vast. I have developed my own little box of tricks, and I've covered pretty much every trick I have, but there will be an awful lot more out there that I have no idea about. Hopefully I've given you at least a few tools so you can go out there and develop your own cool tricks with the circuit networks. As always, questions in the comments and I will answer, yada yada, you know what to do. Till next time.